Good afternoon, class. We are looking at section 3.8, differentials and a linear approximation, part 1. We've covered every section, and now the last one, differentials and linear approximation. Here's the synopsis of that. We're going to go over it in a moment. Reminding you of various differentiation formulas, starting with the definition. dy dx is limit of delta y over delta x as delta x approaches 0, or f prime of x is limit of f of x plus h minus f of x over h as h approaches. Then we look at some theorems, for example, the power rule, or trigonometric functions, product and quotient rules, composite function resulting in the chain rule, as well as the extended power rule, exponentials, and logs. Those are various differentiations we have discussed. Exponentials, the answer is always itself, and then look for more. Logs, flip it over and look for more. Obviously, if you can, you want to decompose it. Also reminding you of logs and what we have discussed. Log x base b equals y. According to this arrow, it means b to the power of y equals x. Bear in mind, b must be positive and can't be 1. Okay, which means when you look at both the exponential format and logarithmic format, they have the same exponent y, they have the same exponent b. Therefore, for a common, a general case where b is any number, as long as it follows the fact that it has to be positive and can't be 1, we have several properties, more specifically 7. Log 1 base b is 0. That means if the argument is 1, regardless of the base becomes 0. Log b base b, that means if the argument and the base are the same, is 1. Log base b of b to the power of x is x. Numbers 3 and 4, for b to the power of log x base b equals x. These two refer to the fact that logarithmic functions and exponential functions are inverse functions. A product rule, quotient rule, and power. In the case of a common log, we just drop the base b. So y equals log x. Log x means log x base 10. And therefore, the properties become more specific. For example, for numbers 1, 5, 6, 7, just drop the base b. But number 2, if the base and the argument must be the same, so when you have log, the base is 10, so you must have the same argument. In the case of a natural log, y equals ln x means log x base e, the base is e. And properties, again, numbers 1, 5, 6, 7, just drop the log and change it to ln. But for example, number 2, why is this ln e? Number 2 says the base and the argument must be the same. This one has the base e, therefore the argument must be e as well. Because exponential functions and logarithmic functions are inverse functions. And then y equals e to the power of x and y equals ln x, if you graph them on the same set of axes, they are symmetric with respect to the line y equals x. Furthermore, if we look at this point, we are looking at the x-intercept. When x is 1, y or ln x becomes 0. For this portion, we are here, and therefore this. That means if x is between 0 and 1, ln x must be negative. And over here, if x is larger than 1, then the function y or ln x is positive. We also have the change of base formula. Log x base b is log x over log b. Choose any base. Of course, the base must be positive and can't be 1. But more specifically, we choose either common log or natural log. And so the derivative of ln x is 1 over x. G of x is 1 over g of x times g prime. And if we have a different base, we also tag along 1 over ln b by the change of base formula. And now section 3.8, differentials and linear approximation. Definition. For y equals f of x, we define dx, or the differential of x, by dx or delta x. So take a look at this function, y equals f of x. It's a curve. P is a point with coordinates x and f of x. Q is a point with coordinates x plus delta x and f of x plus delta x. As we move from P to Q, delta x represents the run. Delta x is equal to dx is equal to bp equals to dc. So they're all the same. I'm going to draw them and then I'm going to erase them. This distance or this distance, we call it delta x or dx or bp. It's just the run. Now we want to discuss the rise as well. But when it comes to rise, it's either along the curve or along the tangent line. So we're going to discuss both of them. Along the curve, it's called delta y. Along the tangent line, it's called dy. So let me erase my work and continue on that dots. And dy, this is the definition, called the differential of y by dy equals f prime of x dx. Why is that? Because as you know, f prime of x is dy dx, therefore dy is f prime of x dx. So if somebody says, okay, find dy, all you have to do, find f prime of x, differentiate the function, and then multiply it by dx. Now, as it was mentioned, what does it mean graphically? If we look at delta y, which is the rise along the curve, is f of x plus delta x minus f of x. Bear in mind, this one is f of x plus delta x. That means this distance. F of x, that means this distance. Rise along the curve. So this is the rise. Rise, remember, rise over run. Okay. So that's the rise. And we can see that delta y is this distance bq, or f of x plus delta x minus f of x, or cq minus dp. dp, this distance is f of x, and cq is f of x plus delta x. So that's delta y. In other words, this distance or this distance is delta y. Now dy, if you draw a tangent line, this distance is rise along the tangent line. So that distance is dy or AB. Is dy the same as delta y? No. By no means. However, we can replace delta y by dy for a function f, which is a continuous and differentiable function with a small delta x, if delta y is difficult to evaluate. So, what are we saying? Let me erase my work. As you can see, delta y and dy are not the same. If delta x is small, by the way, this graph has been blown out of the proportion just to show you the difference between the two, dy and delta y. Again, dx and delta x are identical. But I hope you see that as delta x becomes smaller and smaller, dy and delta y become closer and closer. So therefore, we can do that. Having said that, f prime of x is dy dx can be approximated by delta y over delta x. So here's the synopsis of that. Starting with this one, okay, so delta y becomes f prime of x delta x. So starting with this one, let me give it a number. So number 1, 2, 3, 4. We're going to look at each case. If you look at number 1, is just what we have here. Now, look at this one. If you move minus f of x to the other side, becomes f of x. So f of x plus delta x is f of x plus delta y. So from number 1, we can come up with number 2. Also, we mentioned here about f prime of x is dy dx. dy is f prime of x dx. So nothing brand new. However, what is the fourth one? The fourth one says f of x plus delta x is f of x plus delta y. I can replace the delta y with dy, and this is an approximation. That's it. Then, if we want to come up with the equation of this line, which is known as a tangent line, at this point, which has coordinates a and f of a, we can use the point slope. We know how to calculate that. That is called the linearization. So, linearization refers to finding the tangent line at some point a, y minus y1 equals m times x minus x sub 1. In other words, if I want to find the equation of a tangent line, I'll go with the easy way out, and I'm not going to memorize anything else because the point slope, I already know that. However, if you move the y1 to the other side, negative y1 becomes positive y1. Replace the m with f prime of a, x sub 1 with a, and y1 with f of a. And y is L of x. By the way, this is just the terminology. L of x means linearization, and it means the equation of a tangent line. Do I have to memorize this formula? No, just find the equation using the point slope. Example 1, for y equals f of x equals 4x cubed minus 3x, we want to find dy and delta y when x is 3, dx equals delta x equals 0.2. So the moment you see dy, ignore it, go to f prime of x, which is dy dx. That is 12x squared minus 3. What is dy? The same thing times dx. So 12x squared minus 3 times dx. Now, this is the only calculus step. You can say even this one is calculus step. And now we want to evaluate it, which becomes elementary algebra or basic math. Plug in. What do you plug in? Replace the x with 3, the x with 0.2. So 12 times 3 squared, which is 9. 12 times 9 is 108. Minus 3 is 105. And I hope you see if you multiply 105 by 2, you get 210. You have one decimal, you get rid of one of the zeros, and so you get to only 1. So you can do it in your head very easily. But what is delta y? F of x plus delta x minus f of x, which means f of, add this to 3.2 minus f of 3. Therefore, we are going to go back to original function and replace the x with those two numbers, starting with 3.2, 4 times 3.2 cubed, minus 3 times 3.2, that's f of 3.2. Then plug in 3, 4 times 3 cubed with the minus 3 times 3. I hope you realize this was easily calculated. This can be done by hand, but it takes a little bit more time. So because you have to raise this to the power of 3 times 4 minus 3 times that, and 4 times 3 cubed minus 3 times 3. This is easy. So we get 121.472 for the first bracket, set of brackets, and the second one is 99. The difference is 22.472. As you can see, dy and delta y are fairly close. However, it's important to know, the smaller the value of delta x in a matter of comparison to choice of x, the better this approximation. In other words, if this was 0.1, this would be much closer. And if it were 0.01, they would probably be identical. So for this example, y equals x times 4 minus x quantity cubed. We want to find dy again. And never mind the dy, let's find the derivative, y prime or dy dx. To find dy dx, we're going to differentiate this using the product rule. So this is f times g. Therefore, we need f prime g plus g prime f. F prime is just 1. times g, which is 4 minus x quantity cubed, plus g prime, we use the extended power rule, plus 3 times 4 minus x squared times the derivative of the inside is -1, and now times f, which is x. In other words, this is f prime g plus g prime f. As you can see, we have a common factor of 4 minus x cubed or 4 minus x squared. Obviously, we choose the smaller of the two, 4 minus x squared. If you divide this one by this one, you get 4 minus x. If you divide this one by this one, you get positive 3 times -1 times x, which is -3x. These two combine into -4x. And we can factor -4 out here. We get x minus 1 and we put it in front. So this is dy dx minus 4 times x minus 1 times 4 minus x quantity squared. So what is dy? Same thing, times dx. So write the same thing times dx. Now we want to evaluate dy as well as delta y with the given. So replace the x with 5, dx or delta x with 0.1. When we do that, this is 4, -1. -1 squared is +1. So we are looking at -4 times 4 times 1, which is -16 times 0.1 is -1.6. It's very easy to evaluate. To find delta y is f of x plus delta x minus f of x, meaning it's f of 5 and 0.1. Add them up, 5.1 minus f of 5. Meaning, into this, we're going to put 5.1. So 5.1 times 4 minus 5.1 cubed minus, now plug in 5 times 4 minus 5 quantity cubed. Now, as you can see, this is easy to calculate. You get simply -1, and to the power of 3 is also -1. -5 times -1. But this one, 4 minus 5.1 is -1.1 cubed. You have to take a little bit of the time to calculate it or use a calculator. In any event, without a doubt, this was easier to evaluate than this one. Nevertheless, the two are very close. And if 0.1 compared to x, so in other words, if the choice of delta x or dx compared to the choice of x is the smaller the value, the relationship, the better the approximation. In other words, if this was 0.05, would be much better. 0.01, probably the two would be identical.